You all can hear me, right? Great, thank you. So in lab 6, today's lab, we will be studying about partial fractions decomposition. Okay, I hope you must have came across this method in your lecture section. Are you familiar with this? Have you all studied about partial fraction in your lecture section? No. Oops. Okay. Oh, okay, somebody sees this. Fine. No issues. Okay, so today's lab is all about partial fractions. Why do we use that? How do we do, and how to implement the partial fractions in MATLAB? It's all about that. It is going to be a pretty long or lengthy lab, I can say. So do not get confused at any steps. If you think that you are missing something, just let me know. I can repeat it. Okay. 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 So this is the lab manual for lab 6. Okay. This is all about partial fraction decomposition. Fine. So in this lab, you will have in total 9 problems. And in that, question number 1 is already done, but you will have to include this in your assignment as well. Okay. Question number 1, problem number 2, and problem number 3. Okay. So for all these 3 problems, you are going to apply partial fraction decomposition method. And for the rest of the problems, you can go with U substitution. If not, you can also apply partial decomposition for all these problems. And you can also apply integration by parts. Yes, you need MATLAB code for all the problems from problem 4 to problem 9. So you have to solve all the problems of this lab 6 in MATLAB as well as by hand. Okay. So from problem 4 to 9, you just have to use the 3 lines of code. If you remember, we did in the previous lab. You don't have to perform long division or partial fraction in the MATLAB, only for problem number 4 to 9. Okay, we'll come to that later. Let's not get confused. Okay. So let me start with the example problem. And let's see if I can. Since we have only 3 problems, I will be doing only the example problem. Okay. I can give you some hints on the question number 2 if you need it. Okay. So let's get started. Now, as you all can see here, we have 2 things. One is with MATLAB. So as you can see here, we have to do this with MATLAB and also by hand. Okay. Now, when do we have to use this method, partial fractions, and how? Now, let us see. This is a problem given, right? Now, if you try to apply U substitution for this method, let's say that you take U as x cube plus x. Okay. Now, if you find the derivative, you get 3x squared plus 1, right? Now, can you divide this with the numerator or maybe in the denominator? No, right? Okay, let's say that you take it as x cube or maybe x. Then also you will fail to perform this method. Why? Let's say that you take it as take u as x, then you will just substitute u to the power of 4, u square minus 1, u cube plus u, right? It is nothing but the same division. So the u substitution fails when you try to apply for polynomials with a division, or when you have polynomials as a fraction, then it is very hard to apply u substitution. Okay, then what can we do? All we can do is we need to simplify this function as simple as possible. Okay, now let's say that I have x to the power of 4 plus x squared divided by x. Okay, now instead of applying for the whole function, what can I do? I can integrate this separately, right? Plus x squared divided by x. Agree? Now I can divide this becomes cube, this becomes 1. Now if you integrate, you will get the answer. But what if you have x plus 1? What if you have x plus 1 here? So then in both the denominator, you have x plus 1, right? So this becomes little difficult to apply for u substitution. So now what can we do is we need to simplify this complex function. Okay. Now I will start with hand calculations. I will not go with MATLAB code as of now. Okay. So we will concentrate only on the hand calculations. Okay. The given problem is x to the power of 4 plus x squared negative 1 divided by x cube plus x into dx, right? Okay. Now, first method to simplify this is through long division. Okay, it is nothing like, it is similar to dividing 5 by 2. It is similar to your division method only, but here we will be dividing polynomials. Okay, now after dividing or after applying the long divisions, even after applying this method, if you still have a fraction that you cannot apply u substitution, then what can we do? We will go with partial fractions. Okay, so we will use only the term which has a fraction, and then we will try to decompose it. Decompose means just simplifying the hard functions. Okay, now after applying partial fractions, we will integrate the whole function. Okay, so these are the 3 steps involved in partial fraction decomposition method. Okay, fine. Now, as I said you, the first method is long division. So how does this work? Okay, now I'll just take it as this way. Now, what do we have in the numerator? X to the power of 4 plus x squared negative 1, right? Numerator goes inside, denominator will be in the outside. So x cube plus x. Okay, now what am I trying to find is I need a quotient and a remainder. I'll just call it as Q and R. I need these two things so that I can apply the formula. I can plug these things in the formula. I will tell you what is the formula also. Okay, now how can I minimize this? If I multiply this one, the denominator, with x, I will get the first term. Now I have to eliminate the first term. How do? We multiply this with x. X into x cube is x to the power of 4, right? Now again, x into x gives me plus x square. Now I can subtract these two. But if I want to subtract, you can see that there is a positive sign on both the sides, right? So even though I'm trying to eliminate this term, I cannot because I have a positive term. I cannot cancel this. What can I do? I can multiply only this function with negative so that both becomes negative. And now we can easily cancel the x to the power of 4 and x squared. Okay, understood till now? Do you want me to repeat any steps? Okay. Now, since we have canceled this, what is the only thing that is left out? Can anybody tell me what should I be writing in the remainder term? So I have cancelled x to the power of 4. I have also cancelled x squared by multiplying x to the denominator. Now, what is the left out term here? Very good. She gave me the final answer. So this is -1. Okay, I'll be writing this in the denominator. Now that we do not have any x terms here, we can stop the long division. Now, when can you proceed with the long division? Now, let's say just for an example, okay, just for example, let's say you still have 2x squared -1. What can you do? You can try to minimize this x square into a constant -1. You have to perform till you get a constant. Okay, fine. So now that we got a constant, I'll just keep it as -1 here. Now, how can I write this in the form of fractions? Now we have a quotient plus remainder divided by the denominator. This is the formula for long division. Now, what is the quotient we got? It is x, right? This is q, this is r. So q is x plus r is -1. I'll just put that in the bracket, divided by denominator. Denominator is x cube plus x. Okay, now you can see that we minimized x to the power of 4 x squared minus 1 divided by x cube plus x. You can see that we just completely transformed big function, I can say, into a small functions. Okay, now can I apply integration to this method? Do you think I can integrate this polynomial fractions? I mean, by the direct method, not via partial fractions, but can you apply U substitution or cannot apply integration by parts? So can you apply U substitution or a direct integration method for when you have a polynomials in this way? You can try applying U substitution if you want to. Okay, now let's see, let's try to integrate this fraction. Now, if you try to integrate it, you can always separate, right? This will be negative 1 by x cube plus x into dx. Now, this one, it's not a problem. I can just directly integrate that. But what about the denominator here? If you apply U substitution, again, it's the same problem, right? We get 3x squared. Now, there is no algebraic or polynomial term in the numerator, so it's very hard for you to divide the numerator and denominator, and you cannot apply direct integration when you have in this way. So this is why we use partial fractions. Now I have to simplify the second term here. Okay, we are concentrating only on this term. Somehow I have to minimize this into a simpler function. So I will be applying partial fractions. Okay, don't worry about this. Okay, so now my question is this. It's u plus x. Okay, now I can also write this as x into x square plus 1. I'm just taking x outside. Okay, now how can I apply partial fractions? Remember, partial fractions is a method where you find the coefficients. So whenever you have a polynomial, you will be converting that in terms of constants with the polynomial or coefficients with the polynomial. What do I mean by coefficients? For example, if you have 2x cubed plus x plus 1. What are the coefficients for this polynomial? It is 2, comma. These are called as coefficients. The numbers in front of the x term is called as coefficients. Now for the x cube I have 2, for the x I have 1, and the constant is 1. Okay, now what do you think I'm missing? Any idea about this? This is for x cube, right? This is for x, and this is a constant. Constant. What is this? Yes, that is for x square, because whenever you are writing a coefficients, it has to be in an order. Okay, now there is no x square term in the problem or in the example, right? So we will take it as 0. Okay, so this is for x cube, this is for x square, then we have x and a constant. Constant is also important. Okay, now for example, if you have x square plus x here, then this will be 1, comma, 1, comma, this is 0. Why? There is no constant given here, so we will take it as 0. This is how you have to find the coefficients. Now, in this partial fraction method, we will be converting the fractions into coefficients by writing that in terms of fractions. Okay, when I say partial fractions, that means you are going to write this partial, half fractions, I can say. That means when I say half fractions, I will have some number in the numerator and I will have some algebraic terms in the denominator. Partial fractions. Okay. Okay. Let's see how to write this in a way of fractions. Now, before I get into that, whenever we have x term, let's say I have 1 over x, I can write 1 over x as a to the power of a over x. Okay. Now, what if I have x square plus 1? I have to write it as bx plus c divided by x square plus 1. Why x? I have written x here because we have x square in the denominator. Okay. Since we have x square or we call this as quadratic polynomial. Okay. Quadratic polynomial. If you have x here, this is linear. If you have x square, this is quadratic. If you have x cubed, it is cubic polynomial. Okay, you must know all these basics for your get into the integration. Okay, fine. Whenever you have a linear, that is, whenever you have x term, you will get only one coefficient. Okay, whenever you have x square, that means 2. If whenever you have this 2 as a power, you will be getting 2 coefficients. Okay, we cannot write this as b plus c divided by x square plus 1. We have to include this with x term. Okay, enough with the basics. Let's get into the problem. Now, I will be writing -1 divided by x into x square plus 1 in terms of coefficients as a partial fraction. Okay, now we have -1 over x here. I will write it as a divided by x. Okay, plus, we'll come to the -1 later, plus bx plus c. Why bx plus c? Because we have x square plus 1. Okay, you can ask me, what if I have x square plus 2? But still, whenever you have this, this is the coefficients. There is no change. Okay, divided by x square plus 1. Now you can see that this is the way you split up the denominator. When you split up the denominator, you can apply integration now, because you have x here. Now, can you substitute x squared to the denominator? You can apply u substitution, because when you apply x squared plus 1, du by dx is 2x, right? We also have x in the numerator. You can easily eliminate that, okay? And that's the reason we use this partial fractions. Okay, now, if you want to apply integration directly to this method, it is not possible. Why? Because we do not know what is a, b, and c. We have to somehow find out these coefficients or constants, right? Now, what do we have on the other side? We have -1 divided by x into x square plus 1. Okay, let me erase this. Let me go down here. So we have -1 divided by x into x square plus 1 as the problem. Now I am writing this as a partial fraction. Now you can cross multiply these two, right? You can. So a times x square plus 1 plus x times bx plus c. You should also have x into x square plus 1 in the denominator. Now you can see that you can cancel this one and the denominator in the on the other side because they are same. Even if you cross multiply these two things, you can still cancel. Okay, so I will do that directly in the one step. Okay, what is left out is -1 equal to ax square plus a, because I am multiplying a inside the bracket, plus bx square plus cx, multiplying x inside the braces. Okay, fine. Now I have only -1 on the other side. Now I can group this because I have x square here, I have x square here. So I'll just take the x square outside. I can write it as a plus b plus cx. I'm just writing it in the order because it is 2 here, it is 1 plus a. So this is in the form of example which I showed you, 2x square plus x plus 1. Example, okay? Now this 2 here is nothing but a plus b. In our problem, this is a plus b. And this 1 here is c. This 1 is a. Okay, this is just an example. I'm just letting you, understand. I'm just making you understand what are these a plus b, c, and a. Okay, fine. Okay. Now, okay. So I simplified this, but the problem is I have only one term on the other side. Somehow I have to find a, b, c. How can I find that? Now, whenever I say x square, on the other side also, you must have the same x square term. For example, if you have 2x square plus x plus 1 equal to 4x square plus 5x plus 1. Or let's say a, b, and c. Okay. When you have in this way and they are asking you to find out what is a, b, c, you can always equate these two, and these two. Okay. That's because we have equal to sign here. They are saying that this polynomial is equal to this polynomial. When will that be equal? When a is equal to 2, right? And b is equal to 1 and c is equal to 1. So this polynomial will be 2x square plus x plus 1, and it is equal to the question given. So we are using the same idea here. I have a plus b, I have c, and I have e. But the problem is we do not have x square or x terms on the other side. So what can we assume that as? We will assume that as 0. Okay. So we will take a plus b. We are just working out with the constants or the coefficients. So a plus b will be equal to 0. That's because we do not have x square in the other side. Okay. Now cx is equal to 0. So I'm just directly getting what is c. Now, can you tell me what is a? Very good. So a is -1. Okay, because a is a constant in this polynomial. Okay, here also we have a constant. So I can easily write a is equal to 1. Now, what is b? If a is -1, what is b? Very good. So b is 1. There you go. We got all the constants, right? Now I'm going to plug that in the formula here. A is -1 over x plus b is 1. So I'll just write it as x here. C is 0, so I don't have to write. Now divided by x square plus 1. Okay. Now, can you integrate this? Yes, you can. I will show you how. Let me erase this. Yeah. Do you want me to scroll down because I think I moved faster. Do you want me to scroll down a bit? Okay. Okay. Stop. Now, just to summarize what we did, the question given was x to the power of 4 plus x square negative 1 divided by x cube plus 1 plus x. Okay. Now, what did we do in the first method? Long division. We converted this whole polynomial into a simpler function by applying long division, and we got x plus negative 1 divided by x cube plus x, right? This is what we got. But still, this is not in a simpler form, right? This was not in a simpler form. So what did we do? We applied partial fractions and we got this form. We got the polynomial in this way. X plus, what did we do for negative 1 by x cube plus x? We got this one. So negative 1 over x plus x divided by x square plus 1 into dx, whole term into dx. Agree? Now all you have to do is integrate the whole function. So this, you can take it as x dx. You can keep minus outside and write it as 1 over x dx plus x divided by x square plus 1 into dx. So what is integral of x? X square by 2, right? And what is integral of 1 over x? Log x. So this is x square by 2 minus log of x or ln x plus. How do we do this? Any idea about this? How can we solve this fraction? Yeah, right. So you can apply U substitution. How? I'll take u equal to x square plus 1. Then du by dx is equal to 2x. So what is dx? Dx will be du by 2x. You are going to plug all this here and you will get the answer as ln x square plus 1 by 2. I'm not going to do the entire step because that's what we have been doing from the previous lab. So I hope you all know what is U substitution and how to perform that. So I'm going to stop it there. Okay. So this is how we apply partial fractions by hand. I know that it's too lengthy and you can do this using MATLAB in just 3 lines of code. Now, for example, let's say that you have a very lengthy polynomial as a numerator and denominator, and you cannot apply long division by hand. You cannot perform that, let's assume. And also partial fractions. If you think it is too difficult for you all to do, you can always rely on MATLAB. Okay. Now, how do we perform long division and partial fractions in MATLAB? Let's see that. I'll just explain the code here, and also I'll be doing this in the MATLAB as well. So let me explain the code first. Now we know that we will just say what is X. It is a symbolic variable. So this is a mandatory line to write whenever you are finding out, and whenever you are solving an integral or differentiation, we first have to define what is X. It is a symbolic variable. Sims in MATLAB means symbolic symbol. Okay. So we will first say what is X. You don't have to you don't have to put this apostrophe here. You just have to say what is sims X. You just have to write in this way. Now, we have numerator and denominator, right? So we will call numerator as P and denominator as Q. What is the goal of doing long division? We need to find what is the Q and R, so that I can apply the formula Q plus R divided by denominator, right? So in order to apply this formula, I need what is Q and R, quotient and remainder. Now we need to get what is Q and R. So before I take the whole thing as some function f, instead of doing that, I have to take numerator as P and denominator as Q. Can you take numerator as A and denominator as B? Yes. No matter what is the notation you are giving, but make sure that you enter it separately. Okay. Now we are going to apply a function. We are going to call a function called as QUOREM. QUO stands for quotient and REM stands for remainder. So this is a built-in function in a MATLAB. When I say built-in function, somebody would have built this code. So it will require you to input some numerator and denominator, and that will give you what is quotient and R. So this, in this little parenthesis, whatever we write are called as input arguments. If I want to talk in a computer language, so this is called as input arguments. Whatever you have on the other side, when you specify that with the big braces, those are all the return statements. Okay. For example, let's say I am going to define polynomial. I'll just call it as POLY, and I need to know what is n. I'll tell you what this means, and I will define what is x to the power of n minus 1 plus x to the power of n minus 2 plus so on, and I'm going to return this. I will take it as P, return P. So whenever I give it as n equal to 2, and if I'm calling this function POLY, it will give me x square plus x plus 1. Okay, so if you want this one, that means you have to use a return statement. So you are telling MATLAB what to return. I just need what is p. I don't want what is n, or I don't want each and every term in the x. All I need is p. Okay, so that is the reason we use return. And why do we have to define it as a function? I mean, why don't I just write it as p equal to x to the power of 1, n minus 1, so on, and give it as n equal to 2? You will still get the same answer. Why do I have to define? The reason you have to define is, let's say that you have to say what is polynomial in the other code. Okay, whenever you are performing in the let's say in lab 7 we need what is polynomial of n. If you want to call this function, you cannot. If you define in this way, you cannot call the function. You have to write the code from the beginning. So in order to avoid that, we will define it only once, and we will use it for multiple times. Okay, that's the reason we use the def command for defining a function or a class or whatever it might be. Okay, so let's not dig too much into the coding. Let's stop it here. Okay, so whenever, all you have to keep in the mind is whenever you are giving input arguments, you have to specify that with a parenthesis whenever you need a return statement, or if you need an output of that function, you will specify that with a big bracket. Okay, just keep that in the mind. Okay, so this line of code tells us that I need Q, I need R from the function QUOREM, and I am giving P as a numerator and Q as denominator. When you run this line, you will get this as output. Now you can see that the Q in what we got by hand calculations are same, right? So we performed long division in just 4 lines of code. Okay, let's see how to do this with a partial fraction. Now, when it comes to partial fraction, in this particular problem, I am going to apply partial fraction only for this term, right? Now, what are the coefficients for the numerator? What are the coefficients for the numerator? And what are the coefficients for the denominator? Let's start with numerator. What is the coefficient of numerator in this fraction? -1, right? And what is the denominator? We have x cube as the highest degree. So x cube as a coefficient 1, comma. We do not have x square, so we will write it as 0. We have x and the coefficient of x is 1. We do not have constant, so we will write it as 0. That's how we get -1 here and 1010 in the denominator. Okay, what is this RPK here? Now, we have -1 divided by x cube plus x, right? And we wrote this as a plus b plus c, bx plus c. Agree? Now we will be writing MATLAB answers in the same way. So we want MATLAB to identify the constants R, P, and K. Okay. Now, in order to perform partial fractions, residue is the built-in function. We are calling the built-in function residue, and we are going to give two inputs, that is the coefficients of numerator and the coefficients of denominator. Okay, and what should I expect from this function? I will expect three constants R, P, and K. Understood? So this is how you perform partial fractions in a MATLAB. Make sure that you enter a right coefficients here. Okay. So this was all about problem 1, lab 6. I know it is too lengthy, but if you keep practicing, you will know how to do this. Okay. Now this was the hand calculations which I explained you here. Now let us get into the MATLAB code. So we will be concentrating only on problem 1 here. So let's see, go with problem 1. And I am going with 1A. If you look at your lab manual, it is asking you to integrate the function like you did in the previous lab. So first step is to define what is x, then you enter what is f, that is x to the power of 4 plus x squared minus 1. Make sure you put the parentheses properly, divided by x cubed plus x. Okay, then I just use int and I'm going to integrate function f with respect to x. That's it, very easy. Control enter, you get the answer. You do not have to apply long division, you do not have to perform partial divisions. You get your answer directly. But whenever you are doing by hand, it is required that you have to perform long division as well as partial decomposition. Now, how can we do these two methods in the MATLAB? This is for long division. Okay. Now, I will separate the numerator and denominator. Okay. So numerator, I will just take it as P. You can see that I'm just copying here. So this is my numerator, right? So Q equal to, and the denominator whichever I have mentioned here is x cubed plus x. So this is the denominator. Okay, what do I need? From the long division, I need quotient and remainder. I need only these two things. Equal to, what is the function that will give me these two coefficients? I had explained here, it is QUOREM. That is the function name. You can see that MATLAB is already specifying the function name here. Okay. In the braces, you need what is capital A, capital B. Okay. So that means you need to specify what is the numerator and the denominator. That's it. Control enter. There you go. You got what is Q, what is R, right? So you will just perform long division in just 3 lines. Again. Now, 1C, partial fractions. Partial fractions. Now, partial fractions we apply to find the coefficients of the polynomial, right? So what does the partial fractions need? I need the coefficients R, P, and K. So in the defined function, R stands for residue, P stands for pole, K stands for some kth polynomial or a additional term. Okay. Now, the function which will give me the residue is oops, made a mistake here. So whenever you are entering the input arguments you have to specify inside the parentheses. Okay. Now the residue function needs the coefficients as the input arguments. Now we are going to apply partial fractions only for -1 divided by x cubed plus x. Only for this term, we are going to apply the partial fractions. Now, what are the coefficients present in the numerator? It is -1. That's all, right? Now, what is the coefficients present in the denominator? For x cube, it is 1. I do not have any x squared term, so it is 0. And then I have x here, and I do not have any constants, so I will keep it as 0. That's all. And then we control enter. There you go. You got what is R, P, and K. Now you can see that there is no K. You're just getting big braces there, right? Now that means K doesn't have any element. You can take K as 0. Okay. Now let me come back to the manual here. Erase this. Okay. So we performed this and we got what is R, P, and K. Now, how can we write this R, P, and K as the answer like we wrote here? I mean, we got some answer in terms of X, but whatever we are getting here is just a constant. So what is the formula to write? R will always be in the numerator. In the denominator, whenever you have P, you have to write it in the way like the root. Okay, so let's explain it in detail. So this is R, right? So R will go with numerator always. This is for denominator. You don't have to worry about K because it is 0. Now how can I convert this as a polynomial? How can I write this as a polynomial? It is equal to 0.5. The first number is 0.5. So 0.5 divided by x. Always write x minus I. I because I have I as a first term. So I have R equal to 0.5. So when R is equal to 0.5, P equal to I, right? When R is equal to 0.5 again, P is equal to -I. When R is equal to -1, P is equal to 0. That's what we have here. So R is 0.5, x minus I plus 0.5 divided by x plus I because minus minus is plus. And plus R is -1, P is 0, so I will take it as x. Okay, the formula is R divided by x minus P plus R2 divided by x minus P2 plus R3 divided by x minus P3 plus K. You don't have to worry about this because K is 0. That's how you write the following way. Now, you will cross multiply these two. Okay, when you cross multiply, you will get back this term. So if you are having trouble understanding this method, you can always go with the traditional method, traditional way of solving. or else if you find this as difficult, you can go with this. But I feel that both are same because here you have to find the coefficients first. You will write it as a fraction and then find the coefficients. When it comes to MATLAB, you will write the coefficients first, you will find the coefficients first, and you will write that in a polynomial fraction. So both are same. So, I mean, you can use whichever method is comfortable for you. Okay, so this was all about lab 6, problem 1. Okay, to summarize, first 1A is you're going to integrate the given function using MATLAB, and you will perform long division using MATLAB, and then you will perform long division by hand also, and then partial decomposition using MATLAB and by hand. And then finally, you will integrate by hand to verify the MATLAB answer. Okay, so this is what you're going to do in the lab 6. I know it is too lengthy, but you just have 3 problems, so you don't have to worry. So example 1 is already done. All you have to concentrate is on problem 2 and 3. So do you have any questions till now? Do you want me to repeat anything? Okay. Now you will be doing question number 2 and 3 in the same way. Okay. And when it comes to question number 4, you have to just integrate using int f comma x. There is no need for you to perform long division or partial decomposition in the MATLAB as well as by hand. Okay. When it comes to problem number 4 to 9, 4 to 9, only integrate. You just have to integrate by hand and also MATLAB. Okay. And then you will be uploading this in the Blackboard. So you have to include MATLAB code as a PDF and the lab manual because you will be having hand calculations in that. So you have to upload your hand calculations and MATLAB code as a PDF, merge it and upload it in the Blackboard. Okay. So this will end lab 6. So if you have any questions, please let me know in the chat box or you can unmute and speak. If not, you're all good to go. Happy weekend in advance. I'm not sure. I think we will be having lab next week. Yeah. So we will have lab next week. So I will see you all next week on Wednesday. If you have any questions on the previous lab, you can stay on the Zoom. If not, you are good to leave.